This is Chemistry 2, Unit 5, Equilibrium, Lesson 4 on Le Chatelier's Principle, Qualitative, video number 2. So in our first video, we talked about what is Le Chatelier's principle, and we looked at how a change in concentration of products or reactants will shift an equilibrium system. In this video, we're going to start off talking about changes in pressure or volume. So with this, here we only deal with gases. So if we have something that is aqueous, we really don't worry about this because, well, we're just not going to worry about them. But with this, if we look, a change in pressure affects the volume of something. A change in volume affects the pressure according to our gas laws from Chemistry 1. So if we look at what happens, if we increase pressure, so we're putting things under pressure, that is going to decrease the volume of something, and that will, since we decrease the volume, it increases the concentration, and vice versa, so the opposite. So we can look at this in terms of what happens if pressure or volume changes, and since they're inversely related, we can look at those two. So if we increase the pressure or decrease the volume, what is going to happen is we're going to have a shift to the side of the reaction with the fewer number of moles. So it's like if we go into a crowded room and you have two possible rooms, some people are going to move to the other room to make it a little bit less crowded. So we shift to the side of the reaction with the fewer number of moles. And the opposite is true. If we decrease the pressure or increase the volume and we want to remain at the same concentration, we're going to have to shift to the side of the reaction with the greater number of moles of gas. So again, we want to maintain what we had. So if we have more room, we're going to have to put more things in there to maintain that certain level. So let's look at this example. So here we have an equilibrium system. And if you know that you're going to be doing Le Chatelier's, I kind of always just write the number of moles on each side. So I have 1 here for nitrogen and 3 moles of gas from hydrogen. So I have 4 on this side and I have 2 moles on this side. So we just use the coefficients. They're all gases, so we're good. So we can look at 2 different examples. So here's example number 1. If volume increases. So if we increase the volume, that means that we're going to shift to the side with the more number of moles, because if we increase the volume, we have more space. We want to maintain what we have. Well, we want to get a little bit more crowded, so we go over to the left side. Number 2. If pressure increases. Well, if we increase the pressure, the volume decreases. We have less space. It wants to have a little bit more space, so it's going to go to the side that has fewer number of moles, and that is going to be to the right side. Our next stressor is a change in temperature. So this means that we're going to add or subtract heat. So with this one, we are going to treat heat as a product or reactant. So we are going to be using some terms from thermodynamics. So we're going to be using delta H and endo and exothermic. So if you recall, a positive delta H is endothermic, and a negative delta H is exothermic. So if heat in kilojoules or joules is put into an equation, endothermic, it's going to be a reactant. Exothermic means heat is given off, so this is treated as a product. So if we have an equation like this, endothermic, where heat is a reactant, if we increase the temperature, that means that we're adding heat. If we're adding something to the reaction, just like we did with the change in concentration, it moves to get rid of it, so it is going to shift to the right. If we have A plus B and we have an equilibrium reaction, C plus D plus heat, so this one is exothermic because heat is given off as a product. If we were to increase the temperature here, again, it wants to get rid of it, so it's going to shift it to the left. So we're removing heat, and it shifts left. Instead of removing, let's say giving off. So again, if we cool this reaction down, we're removing heat, it's going to shift to the left. This one, if we remove the heat from here, it's going to shift to the right. So here is another reaction. Here we have our Haber process, and we're given a positive delta H, which means that heat is on this side. So if we increase the temperature of this reaction, we're adding heat in, it's going to shift to the right. Our last thing is an addition of a catalyst. This has no effect on K, so there's no shift. All a catalyst does is it causes the reaction to reach equilibrium faster. So you have two packets that you are going to be working on. The first packet looks like this, and this will be labeled Packet 1 on Schoology. So some of these are multiple choice, and you can just work through this, and we'll check it in class. Number 2 packet on Schoology, this is what it looks like, and it's missing this page on Schoology. So I'm going to add this in, but this one is asking questions again and completing some charts. So you are free to go ahead and begin working on these packets.